Hi there, this is Nilesh Sen, Assistant Professor, Computer Science Department of Infinity Management Engineering College, Sagar. Today, in this very video, I'm gonna describe about types of parsers as it is most important to learn compiler design so as to work with parsers. As you can see in this very screen, that there are two types of parsers available, that is top down parsers and bottom up parsers. Top down parsers is further divided into two: top down parsers with full backtracking and top down parsers without full backtracking. Top down parser with full backtracking is also called brute force parser, whereas top down parser without full backtracking is further categorized into two, that is recursive descent parser and other one is non-recursive descent parser. Now come to bottom up parsers. It is also known as SR parsers, where SR stands for shift reduce parsers. Bottom up parsers further categorized into two, that is operator precedence parser and LR parsers. Now come to LR parser. It is further categorized into four, that is LR0, SLR1, CLR1 and LLR1. Now let's have a look what is the differences in between these, means top down parsers and bottom up parser. Top down parsers start at the root of the derivation tree and fill in subsequently. In this very parser, one need to pick up production and tries to match the input. Top down parser may require backtracking, and some of the grammars are backtrack free. Those are also known as predictive one. Top down parsers cannot handle left recursion in a grammar. That is the very most important thing that each and every one must know before dealing with the top down parser. Now come to bottom up parser. It start at the leaves and fill in upward, as name indicating bottom up. It start in a state valid for a legal first tokens, means actually in the shift reduce parsers or bottom up parsers, it works with the tokens and it is having a look ahead of length 1 and length 0 as well. So it start in a state valid for legal first token. As input is consumed, change state to encode possibilities, means recognizing valid prefixes is must. It uses a stack to store both state and sentential form as well. In this very video, I'm gonna describe about top-down parsers only. So as you can see in this very screen, Top down is for also known as recursive descent. It is having two categories, that is backtracking and without backtracking. So without backtracking is also known as predictive parsers and LL parsers. One more thing, uh, C, C++, both uses recursive descent parsers, but if the grammar, context-free grammar is having some complex information with it, then it will go with the operator precedence one. Otherwise, for the normal grammar, recursive descent parser is good, and C, C++ generally use it for the smaller subset of grammar. Top-down parser. Before getting deep into this, one need to learn about CFG, context-free grammar, and you people well known about this, or can say you learned it earlier in earlier classes of theory of computation. So considering that you guys are very well aware about context free grammar, so top before dealing with the top down parser, it is based on leftmost derivatives. That means it works with LMD, and in this very parser, CFG must be free from ambiguity and must be free from left recursion and left factoring too. The process of constructing the parse tree, which starts from the root node and goes down to the leaf, is top down parsing. Now come to brute force, or can say recursive descent parsers. Whenever a non-terminal is spent first time, then go with the first alternative and compare with the given input string. If matching doesn't occur, then go with the second alternative, and if again the matching doesn't occur, then go with the third one, and so on. We repeat the same process till then the input string got matched. If matching occurs at least for one alternative, then only the input string is passed successfully. It is also known as backtracking passes. Here is the example, guys. Let us consider that the CFG for backtracking is S produces RXD, and second production of our CFG is X produces OA, and third production of the given grammar is X produces EA. And suppose we are asked to produce read as an output string, then as backtracking parser says that it starts from the root node, therefore we'll start with the very first production, that is having a start symbol. In this very grammar, here it is S. So S is producing only one production, that's why we'll go with it. S produces RXD. Since in this very production R and D both are terminals, they will not gonna produce any productions. Now at this very level, X is the only non-terminal, or can say variable, so we'll go with the second production, that is X produces OA. While applying this production, what we are achieving, we are getting ROAD as an output, but what we require, that is READ, read, not road. That's why we have to backtrack again, but not we have to go till root, but at this very instance we have to reach at back to x. Now from the x we'll go with the next production, that is EA. Now finally we got READ as an output. As you can see, S produces RxD, then X produces RxD, and further X produces OA. Since we didn't got since input string doesn't matched, therefore we will backtrack, will reach back to X and then perform uh, another production and finally got read as an output. Thank you.